Hi, so we're going to continue a part of the linear equation, but this is all just word problems. So what kind of word problems are we doing? We're going to do problems involving numbers and geometric problems. We're going to do rate time problems, and we're going to also do mixture problems. So these are just part of single variable linear equation problems. So let's start with the first one. It says, find four consecutive even integers such that the sum of the first three exceeds the fourth by 8. So this looks kind of weird, really weird. So what we have to do is we got to find. So how we solve this is reread it until find four consecutive even integers. So even is like 2, 4, 6, such that the sum of the first three exceeds the fourth by 8. Okay, so we don't know. So let's say even integers. We don't know what are even integers, so let's call even integers equals x. So let x equals the first even integer, right? So we have an x. This is my first consecutive even number, consecutive even integer. And then our second even integer is x plus 2. So this is my second. My third one is x plus 4 because we want it's 2, 4 because we want even numbers, so it's x plus 4. My third even consecutive integer. And then my fourth one is x plus 6. It's my fourth even consecutive. Okay, so when they say sum of the first three equals the fourth plus excess. So let's see here. On the left side, it says sum of first three. So what does sum mean? You just add all the first three. So we're going to add x plus the first three, right? So it's x plus 2 plus x plus 4, right? Equals fourth plus excess. What is my excess? 8, right? The excess is 8. Yeah, by 8. Exceeds the fourth by 8. So what's my fourth term? My fourth is x plus 6, right? Right here. And then plus 8, because that's my excess. Let's simplify the left. So we have an x here, so that's 3x. Plus 6, because 2 plus 4 is 6. Equals, let's fix this one. X plus 6 plus 8 is what? 14. So it's x plus 14. Okay, so let's solve. My goal is to solve for x. So let's get all the x's on one side and all the numbers on the right. So let's move this 6 over here, move it to the right. So I'm going to subtract 6 from both sides. So we have 3x equals x Okay, 14 minus 6 is what? 14 minus 6 is positive 8. So now my goal, so let's get all the x's on one side, so let's move this x to the left. So subtract x. So 3x minus x is 2x equals 8. Divide everything. My goal is to solve for x, so divide everything by 2. So x equals 8 divided by 2 is 4. Okay, so we found x. So let's just plug in x. Wherever there's an x. So we have an x plus 2 plus 4. Let's see. So if you plug in x into that equation, you're going to get x, which is 4. So let me write it down here. So if you plug in x into that equation, you're going to get 4, 6, 8, and 10. So those are the 4 consecutive even integers. Yeah, that is my fourth consecutive even integer such that the sum of the first 3 exceeds the fourth by 8. Let's do this one. Oh, triangle one. Oh, goody. So it says if one side of a triangle is 1/3 the perimeter, the second side is 1/5 the perimeter, and then the third side is 7 meters. What is the perimeter of the triangle? So when you do this problem, you always gotta be very visual. You just have to like draw as much as you can. So it says one side of a triangle is 1/3 of the perimeter, the second side is 1/5 of the perimeter, and then the third side is 7 meters. What is the perimeter of the triangle? Yep, let's draw the triangle. So let's draw. So it says one side, we'll call this A, B, C. The C is always the biggest because it's the hypotenuse. So if one side is 1/3, so we'll call this 1/3. And then the second side is 1/5, so we'll call this the 1/5 of the perimeter. And then the third side is 7 meters, so this whole thing is 7 meters. Find the perimeter. So let's find, so P equals the perimeter. And then remember how to find perimeter, you always have to add all the sides. So we're going to add A plus B plus C, right? Because that's just finding the perimeter. You add all the sides. Now remember, the perimeter for A, for side A, is 1/3. 1/3 of the perimeter, 1/3 P. And the perimeter of this side is 1/5 of the perimeter, so it's going to be 1/5 P. And then we know that the C is just regular 7 meters, right? Just you add 7. So my goal is to solve for P. So let me rewrite this again. P equals 1/3 P plus 1/5 P plus 7. So I want to solve for B, so I need a common denominator. So over here we have an invisible 1. Over here we have an invisible 1. So we have 1, 3, 5, and 1. So what is my common denominator? 15, right? This bracket means we're going to multiply everything by 15. So this is just going to be 15p. 15 times 1/3 p is 5p. plus 15 times 1/5 p is 3p, and then 15 times 7 is 105. I mean, yeah, 105. Let's see here. Let's fix this the right. So the p can't combine. So 5p plus 3p is 8p. Plus 105. And then you have a 15p right here. Let's see, our goal is to solve for p, so let's move this 8p to the left. So I'm going to subtract 8p. Subtract 8p. 15p minus 8p is 7p. 7p. This cancels, so you're left with 105. Divide everything by 7. Divided by 7. So our p is just 15 meters. Because 105 divided by 7 is 15, and it's measured in meters. So that was that one. More rectangles. I see a lot of this problem a lot when I was tutoring, so this is a very common perimeter problem. So it says find the dimension of a rectangle with a perimeter of 54 meters if its length is 3 meters less than twice its length. So first step is what I'm going to do is I'm going to always draw a rectangle. So they says what do we know? We know the per meter is 54 meters. We know this is the length, and then we know this is the width. They say that the length is the length is 3 meters less than twice its length. How do we write that? 3 meters less. So we know less means subtraction, right? So we're going to put a minus here. 3 meters less is less than 3 meters, so it's going to be a minus 3, then twice its length. Twice its length means it's 2 times L. So it's 2L, 2 width, 2W. Twice its length. Yeah, 2W. So it's 2W minus 3, right? So let me reread this. So if its length is 3 meters less than twice its length, this should not be length, this should be width, sorry. So it's 2W minus 3. And we'll leave W as W. So we got to find the dimension. We got to find the length and the width, right? We got to find the length and we got to find the width. Well, how do we do that? So we'll just stick with what we know. Remember, with perimeter, you add all the sides and then that should give us a perimeter. So we know the perimeter is 54. So if you add everything, you get 54. So what is my length? Our length is 2W minus 3. 2W minus 3. But there's two of them, right? There's a length here. So we're going to multiply this by 2. And then what is my width? We could just call it W. So we'll just call it W. But there's two W's, right? 2 width. So it's plus 2W. And then that should equal 54. If we FOIL this out, we get 4W minus 6 plus 2W equals 54. Let's simplify. 4W plus 2W is 6W minus 6 equals 54. So my goal is to solve for W, so I'm going to get rid of this minus 6. So I'm going to add 6 to both sides. 54 plus 6 is 60 equals 6w. Let's see here. Let's solve for w, so I'm going to divide everything by 6. So w is 60 divided by 6 is 10. So our width is 10, right? W equals 10. Now, what is my length? Remember, length is 2w minus 3, so it's 2 times, we know our width, right? It's 10. 2 times 10 minus 3. If you do that, if you do all the calculations, you're going to get 2 times 10 is 20, minus 3 is 17. So my width is 10 meters, and then my length is 17 meters. Or we can say 17 by 10 meters. So that's how you solve it for that one. Okay, this one's kind of, this is a, what is this? This is called my rate problem. So if you could go back to the first video, it has all the notes of rate problem. Actually, let me show you. You can press pause on this part. This gives us the rate problems. So rate equals Q over T, or quantity over time. Quantity is rate times time. Time is Q over R, or quantity over rate. And then if Q is the distance of D, then R equals D over T, and D equals R times T, and then T equals D over R. So an example of time would be like knots. And then I think that's what we're going to use for our problem, because we are dealing with ships, so it's dealing with knots. So let me reread this. This is kind of long. They say the distance along a shipping route between San Francisco and Honolulu is 2,100 nautical miles. If one ship leaves San Francisco at the same time, another leaves Honolulu, and if its former travels at 15 knots, and the latter later at 20 knots, how long will it take the two ships to rendezvous or meet? How far will they be from Honolulu and San Francisco at that time? So the first step is you always draw a visual. So let's draw a visual. We'll call this point Honolulu. I'll call it big H. Honolulu, and then over here we have San Francisco, SF. So this is San Francisco, this huge land. And then the distance from there is a total of 2,100 miles. So from here to here is 2,100 miles. So, and then let me draw it on a number, like a number line. So here's Honolulu, here's San Francisco. Here's where they're going to meet, right in the middle, so this is the meeting. So distance 1 or ship 1 has 20 t, because it's time, because it's 20 t or 20 knots. So distance 1 is going this way. So yeah, time is, when I say knots, so time is like quantity over rate. So that's why I say d over 1. D is 20 t, or 20 time, which is measured in quantity over rate. And then d2, distance 2 or ship 2, is it's 15 t or 15 knots. So distance of ship 1 I think it's, yeah, this one, from Honolulu travels to the meeting point D. Point. So that is why we call it D1, or 20t. And we're going to add the second distance of ship 2, right, from San Francisco travels to meeting point. So we call that D2, or 15t. And then that should equal total distance from Honolulu to San Francisco. And then that equals 2,100 miles, right? 2,100 nautical miles. Okay, so when you add 20t plus 15t, that gives my 35t. And that gives you 2,100 miles. Solve for t, so divide everything by 35. So the time is 60 hours, or 2.5 days for the ship to meet. So So now we got to find the distance from Honolulu from H. I call it Honolulu. I'll just write it out. Honolulu. So what is my distance? So we know that distance is the same thing as rate times time. So what do we know our rate? Our rate is 20, right? 20t. And then our time is 60 hours. So times it by 60. So that gives us 1200 nautical miles. And I don't know what nautical means. Nautical miles. And then distance from San Francisco is, so we know distance is rate times time, so my rate for the second ship is 15t times it by 60 hours, and then that gives me 900 nautical miles. So it says, so if one ship, so we know, okay, so hold on. So we know everything now. We know how far, okay, so they know that how long will it take the two ships to rendezvous? It would take a total from here to here. It's going to be 60 hours or 2.5 days. And then from this distance, oh wait, right here, from this distance from here, ship 1, it's 1200 miles. And then from ship 2, it's going to have 900 miles. So the one, yeah, so the one with the less speed has less miles, and the one with the highest speed, ship 1, has 1200 miles. So that's kind of strange. So let's do, I think we have a few more and then we're done. Another distance problem, distance rate time problem. So this one says, so we have an excursion boat that takes 1.5 times as long to go 360 miles up a river than to return. If the boat cruises at 15 miles per hour in still water, what is the rate of the current? So first I got to draw a visual. Here's my current. So here's my current. Here's the water. Blah, blah. Water, water, water. So remember, current has two ways. It could go this way, and then it could go downwards. So let's say, what do we know? We don't know the rate of current in miles per hour. We don't know that. So we'll call that x. Let x equals rate of current in miles per hour. Right? We don't know that. So let me reread the problem. An excursion boat takes 1.5 times as long to go 360 miles up a river than to return. If the boat cruises at 15 miles per hour in still water, what is the rate of the current? So yeah, we don't know the rate, so we'll call that x. What else do we know? Okay, so remember how I said current can go this positive and it can go negative. So let's find the rate upstream, this boy. Rate of boat upstream. So upstream, actually we're going to go negative. We're going this way. This is what upstream means. So when you go down this way, it's going to be 15 minus x, because they say that the boat cruises at 15 miles per hour, right? So if it's going down this way, it's going to be negative x. Going downwards, negative x. And then rate of boat downstream is 15 plus x, right? Remember, downstream, you're not going negative. When you go downstream, you're actually increasing speed, so that's why it's positive. So we got to find the time upstream. Time of upstream is equal to 1.5 so 1.5 times the time of downstream. So, okay, so let's remember from our formulas, recall that time equals distance over rate. So what that means is distance upstream over rate upstream equals 1.5 times distance downstream, and then divided by rate downstream. So what is my distance upstream? Remember, the distance upstream it says it goes up to 360 miles, 360 miles. So excursion takes 1.5 times as long as to go 360 miles. So my distance is just 360. So you put a 360 right here, divided by what is my rate of upstream? The rate of upstream is 15 minus x. Yeah, 15 minus x is my rate of upstream. And we got that from here. Rate of upstream is 15 minus x. And then that should equal 1.5 times distance of downstream is 360 divided by rate of downstream is 15 plus 6. let's see, let's fix this up. Let's fix the right side. So 1.5 times 360 is 540 divided by 15 plus x. And then this is just 360 minus 15 minus x. So now we can cross multiply. Let's cross multiply this and cross multiply that. So on the left you get 5400 plus 360x equals 8100 minus 5400x. Okay, so now our goal is to solve for x. So what I'm going to do is subtract 5400 from here. Get rid of that 154. So you're left with 360x. 8100 minus 5400 is 2700. Minus, bring down the negative 5400x. So what do I have to do? Let's move that 5400 to the left. Left. So I'm going to add 5400. So I get 900x. So that cancels. 900x equals 2700. My goal is to solve for x, so I'm going to divide everything by 900. So x equals 3. But are we done yet? I don't. So the question is, asks, what is the rate of the current? And the rate of the current, so rate of current is 3 miles per hour. That's it for this problem. Yay, one last problem. And then this one is my last problem, I promise. Let's do a mixture problem. So it says, mixture problem. How many liters of a mixture containing 80% alcohol should be added to 5 liters of a 20% solution to yield a 30% solution? So let me just draw a little something. So we have a flask, right? We have a flask. They say that this one is X liters. We don't know it, so that's why we call it X liters. And then they say that this is 80%. 80% solution. Right, 80%, so I think it's 80% alcohol, yeah. So that's the 80% alcohol solution. And then if you add another solution, here's my other flask. This one's a little bit more. This one is about 5 liters. So this one's 5 liters. And this one is 20% solution. If you add all those together, you're going to get this. You're going to get X plus 5 liters So this is this whole thing is before mixing, right? This is before mixing. So the amount of alcohol in the first solution, so amount of alcohol in first solution is, what would that be? 0.8x, right? How I got that is, how do you write 80% in decimal? 80% into decimal. You move the places, 2 places to the left, so you get 0.8. So it's 0.8 and then it's the x, right? 0.8 times x is just 0.8x. How would you, what about this one? This one is the amount of alcohol in second solution. So how much is this? 20%? Yes, 20%. How do you write that in decimal? It's 0.2, and then you times it by 5. So it's 0.2 times it by 5, and then that should equal amount of alcohol in mixture. So how much? So it's 0.3, right? What is it? 30%? Yeah, so it's 0.3 0.3 times it by x plus 5. So let's see, let's do some math. So 0.8x plus 0.2 times 5 is just 1, positive 1, equals, when you FOIL that out, 0.3 times x, so it's 0.3x, and then 0.3 times 5 is positive 1.5. Let's solve for x. So let's see, how do we do this? Let's move this 0.3x to the left. This cancels. So 0.8x minus 0.3x is 0.5x, and then plus 1 equals 1.5. Let's move this 1 to the right, so subtract 1, subtract 1. So we get 0.5x equals 1.5 minus 1 is what? 0.5. So we're going to divide everything by 0.5, divided by everything by 0.5. You get x equals 1, right? So what does the question says? It says, how many liters of a mixture containing 80% alcohol should be added to 5 liters of a 20% solution to yield a 30% solution? So what they're asking is, how much liters for this, and when you add this amount, you're going to get this amount. And we said it's just 1 liter. You just add 1 liter of the 80% solution. Yep, that's it. That wraps it up for this section.